Hello guys, so welcome to our channel, Run Basic. So in this video, we will learn how to solve for your asymptotes of your rational functions. So asymptotes of your rational functions can be in vertical and horizontal, and sometimes um, we can also see an oblique asymptote. So let us discuss the definition of your asymptotes. So asymptotes are lines or can be a curve where the graph of your function gets closer and closer or approaching or approaches but does not touch or intersect until infinity. Okay, so that is the definition of your asymptotes. So we have three asymptotes. We have the vertical, the horizontal, and the oblique, or some say that it is known as your slant asymptote. Okay? So by definition, the vertical asymptote is denoted by x equals to a, and your horizontal asymptote is y equals to b. So you can use any variable a or b or any variable to denote your vertical and horizontal asymptotes. And later we also discuss on how to solve for your oblique asymptote. So to solve for your vertical asymptote, we have to reduce your function by factoring and then simplify and equate your denominator to 0. So your denominator. So on the other video, your denominator is also used in finding your domain. So the vertical asymptote and the domain has some relationship. Okay? Then we are on your horizontal asymptotes denoted by y equals to b. So in computing your horizontal asymptote, we have to identify and compare the degree of the numerator and the denominator. So we have here some, assuming the degree of your numerator is n and the degree of your denominator is m. So, example, we are comparing the degrees. Your numerator is less than your denominator, then your asymptote, horizontal asymptote is y equal to 0. Number 2 condition, when the degree of the numerator and the denominator are equals, we will have to divide the leading numerical coefficient. So I will discuss it later. And then this one we have, when the degree of the numerator is greater than the degree of the denominator, therefore, there is no horizontal asymptote. Okay? Going to our slant or oblique asymptote, it only occurs when the numerator of f of x has a degree that is 1 higher than the degree of the denominator. Okay? Then divide. To solve it, we have to divide the numerator by the denominator using synthetic division or the long method of division. And then this one, the condition, the oblique asymptote is the quotient when we divide with the remainder ignored. So these are just definitions. Now let us go to the actual examples of real functions or rational functions, and let us solve for the vertical, horizontal, and the oblique asymptotes. Okay, so let's go. Okay, now so let us proceed to our first example. We have here on the board your first function f of x equals to 3 minus x over x plus 1. So we have to simplify your f of x into the form of y. Okay, so we have y is equal to, copying, 3 minus x over x plus 1. Then we have here on the board some hints on how to solve for your vertical, horizontal, and oblique asymptotes. Okay, so your vertical asymptote, we have to solve for the denominator. So the denominator is x plus 1. Then equate it to 0 and solve for x. So we have x equal to negative 1. So if you can recall, or you can see on the other video, this value and this example, It's like solving your domain and range. So x equal to -1, the value is just like we are solving your range. Okay? Sorry, solving your domain. Okay? So let us proceed. So the equation of the line of the vertical asymptote of your rational function is x equal to -1. So very easy. So now let us proceed to your horizontal asymptotes. So horizontal asymptotes comparing the degree. So we have to look at the given rational function, this one, or you can look at this. So the degree of our function, by looking the numerator and the denominator, so the degree of the numerator is 1, and the degree of your denominator is also 1. So we are on the linear degree. Both are on linear degree. So when the degrees are the same, so we have to solve it as y equals, okay, so let us solve this part. So we have y equals to a over b. A over b denotes the leading numerical coefficient of your numerator and denominator. So when we say leading numerical coefficient, the number or the numerical coefficient of your variable x. So on your numerator, so let us write it here. Y is equals to 3 minus x and x plus 1. The leading coefficient here is 1 and 1. Okay, so your numerator, the leading coefficient of your numerator is -1. The leading coefficient of your denominator is +1. So we have y equal to -1. So the equation of the line of your horizontal asymptote with the given function is y equal to -1. So if you will have to notice, your vertical asymptotes has some connection with your domain, and your horizontal asymptote has some connection with your range. Okay? So, assuming we have to put a sample of your graph, okay? Just a sample. But if you can open your graphing calculator and check the graph of this rational function. So graphing x equal to -1, assuming we have x equal to -1, -2, -3. -1 is here. Okay? And then your asymptote is denoted always by a broken line. Okay? A broken line. So this is your vertical asymptote. Okay? So how about your horizontal asymptote? So we have examples. We have your units, -1, -2, -3, and -4. Then your horizontal asymptote will pass through at y equal to -1. So this is your horizontal asymptote. Okay? So the graph will look like this. Okay? And this. Okay, so if you will be asking, how about your oblique asymptotes? So oblique asymptotes, our hint here is also the degree. Checking the degree of the numerator and the denominator. Okay, so what is the degree of the numerator? 1. The degree of the denominator is also 1. So when the degrees are equal, we have no oblique asymptote. Okay? Simple as that. An oblique asymptote occurs when the denominator has a degree of greater than 1 comparing to your denominator. So example, the degree of your numerator is 2 and the degree of your denominator is 1, then we can solve for your oblique asymptote. Okay? But I will show you the oblique asymptote on the next examples. Example, we have the function h of x equals to x squared over x plus 2. So you can put it in y equal to x squared over x plus 2 if you want. Okay, then solving for the vertical asymptotes. So vertical asymptote, then focus on your denominator. So we have x plus 2. Equate it to 0. Solve your x. Then the equation of your vertical asymptote is x equal to negative 2. Simple. Now let us proceed to your horizontal asymptote. So your horizontal asymptote, let us compare the degree of the numerator and the denominator. So the degree of your numerator is 2 and the degree of your denominator is 1. So n is greater than m. So we can say that we don't have horizontal asymptote. Okay? We don't have horizontal asymptote. So let us proceed to the oblique or slant asymptote. Okay. So if you can see the degree again, our hint is the degree. The degree of the numerator is greater than 1 comparing to your denominator. So we can say that we have an oblique asymptote. So your oblique asymptote here, we have to divide your numerator by your denominator like this, using your long method of division. So dividing x squared divided by x. So we have to subtract the exponent. So we have x. Checking x times x, we have x squared. X times 2, we have plus 2x. Then subtract, negative, proceed to addition, cancel, we have negative 2x. Okay, so the rule of your subtraction, if you can check the other video, we have to change the sign of the subtrahend and proceed to addition. Then we have 2x divided by x. Again, 2x divided by x. This one, 2x divided by x. So we have 2 or negative 2 remaining. Then negative 2 times x, of course, negative 2x. Negative 2 times 2, so we have negative 4. Subtract, change the sign of the subtrahend, and proceed to addition, cancel, so we have positive 4. So we will have to ignore your remainder. The oblique asymptote is always on this form. So it is a slant line, or oblique is said. So it has slope. So it will follow your slope-intercept form of y mx plus b. Or in this case, we have your oblique asymptote, which is equal to, it's right here, y is equal to x minus 2. Okay? So checking the graph will look like this. If you have to check it by yourself, then you can check it. So your vertical asymptote is negative 2. So we have negative 1 in here, negative 2, and negative 3. So your graph will pass this broken lines. Okay? So we don't have an horizontal asymptote. And your line, y equals to x minus 2, will pass in here. Your y-intercept is negative 2. Okay, so this one, your x-intercept will be positive 2. Okay, so this slanting line is your oblique asymptote, and the graph will look like this. this one. Okay, so you can check using this apps, Desmos and GeoGebra. You can install it on your phones. Okay, so let us proceed to another example. Okay, so we have the function g of x equals to x squared minus 3x plus 2 over x squared minus 4. So before we can solve your vertical, horizontal, and oblique asymptote, let us first simplify your function g of x. So let us directly convert it into y form. Then unfactored form. So if you can see, both are in quadratic degree, and it means that we can factor. So factoring your x squared, so we have x times x. Factoring your positive 2, we have 2 times 1. Then the sign center is, or the middle term is minus and minus. Negative times negative is positive. Negative plus negative is positive. 1 and 2 is 3. You can check it using FOIL method or distribution property of multiplication. Or you can check my other video on how to factor this one. Then we have your denominator. X squared minus 4 is difference of 2 squares. So the factors, the difference of 2 squares is plus, minus, or minus and plus. You can change. Then 2 times 2. 2 times 2 is 4. X times x is x squared. Plus 2 and minus 2 is 0. That is why this denominator don't have a middle term. Okay? Then, if you can see, the common is x minus 2. Okay. Don't forget the common factor, x minus 2. Okay. So, your simplified form of function now is y. Your numerator now is x minus 1 and your denominator is x plus 2. So we will use this function. Then solving for your vertical asymptote, focus on the denominator. So x plus 2 equals 0. So x is equal to negative 2. So the equation of the line of your vertical asymptote is x equal to negative 2. Okay? Going to your horizontal asymptote. Your horizontal asymptote, compare the degree of the numerator and the denominator. So both are in linear degree. So when the degree are equal, n is equal to m on our condition, so we can say that y, we have to divide the numerical coefficient 1 divided by 1. Okay? So we have y equal to 1. Okay. Let's go to oblique asymptote. So therefore the degree is equal. So therefore we don't have an horizontal as oblique asymptote. So no oblique asymptote. But I will discuss the concept of this one, pole or poles. So in some branches of mathematics, it is known as the removable discontinuity. Okay? So if you can remember this one, the common factor of your reducing in here, the common factor is x equal x minus 2. Weight it to 0, therefore your whole is x equal to 2. So I will show you the case of this whole. Okay, so holes, if you have 2 or more common factors. So in our case, we have one common factor, which is the x minus 1. So your vertical asymptote is x equal to negative 2. So negative 1, negative 2, and negative 3, negative 4. So broken line. So this is your vertical asymptote. Then your horizontal asymptote is on y equal to 1 in here, denoted by broken line. So we don't have any oblique asymptote. Okay? Okay, now let's proceed. 1, 2, 3. Negative 1, negative 2, and negative 3. So the graph will pass or look like this. And another is this one. So it's not the exact graph, but it will look like this, and at x equal to positive 2, we have discontinuity. Okay? Discontinuity. So this is the whole of your rational function. Okay? So later I will discuss the relationship of your vertical asymptote to your domain and the relationship of your horizontal asymptote to your range. Okay, so I guess that you have learned something from this video. Thank you so much. Stay safe and please subscribe.